So here is the ideal op-amp model. And the rules, these 3 rules, are sometimes called the golden rules. It's the rules you remember. You just have to remember this, and you don't have to remember anything about input resistance inside the amplifier, output resistance inside the amplifier, or what the specific open loop gain A is. You just don't have to remember that at all.
That would be great. It would simplify analysis a lot.
And it will, you'll see. I mean, the problems go blindingly fast once you make these assumptions. But let's talk them through so you know where they come from. And again, we can kind of walk you through some pitfalls. Okay, first one, the first rule is pretty easy to understand. So if I have this input resistance we've talked about many times now, and I tell you that this goes to infinity, what's input resistance of infinity?
It's infinite. It's like an open circuit.
It's an open
really.
circuit. So what current's going to go through an open circuit?
Zero current.
Exactly.
Zero current.
So you know that these must be 0 simply because we've said that this model assumes that the input impedance is infinite.
And thinking about when to apply it, if you look at the input impedances of our amplifiers by looking at the data sheet, we can tell that they're usually rather high.
Right.
So what if whatever we're trying to attach to it has a much lower resistance? We're good.
Great, perfect. Okay, so that's the first one, check. Now, the second one is the weirdest. So the second one is the one people have the most trouble with, in particular because we don't really tell you what the insides of these amplifiers look like with transistors. So let me try to give you a sense of what the second one is. The second one says that this voltage is equal to that voltage. And you might say, wait a minute, that's crazy, right? You just told me there's an open circuit there, there's no current. How could that, those things seem to be almost like counterintuitive or conflicting. Yeah. Okay, what's the trick? The trick is that these golden rules work when the amplifier has a negative feedback path. It's got some external circuit that's also got a negative feedback.
Okay, so the output has to some way be connected back to the negative input.
Right, and what we don't discuss in this class or in these series of videos is what constitutes good negative feedback and sort of all of the detail in that, which is a beautiful body of sort of literature. It's a wonderful field of study, and I encourage you to go learn all about controls and systems to kind of get a handle on this. But for the moment, we'll assume that whatever negative feedback is there is sufficient to make all this work. And so then the way to think about it is, see, if the internal open loop gain of this amplifier is huge, that means any tiny little change in the difference between these inputs is going to produce a fairly substantial, potentially a fairly substantial output. And that'll cause current to change, the current going through this feedback path to change. And the key is, and this is, I'm hand waving, but just so you understand what's actually going on, the key is that this negative feedback path, when it's a negative feedback, it's going to work, that current is going to work to minimize